Hi everyone, we are going to start Cambridge IGCSE Investigation and Modeling paper for the section October-November 2025. The subject is Cambridge International Mathematics and the code is 0607. This is the paper 6 and the variant is 1. Section 1, this is the investigation section, square rings. You are advised to expend no more than 45 minutes on this section. In this investigation, you will work with number along the inside edges of two squares drawn on the number grid of width 10. The diagram shows part of this number grid. On the grid, a 4x4 square surrounded by 2x2 square. The shaded area formed by 4x4 square ring. A square ring is always one square thick. We have this one is a part of the grid. It may be 10 times something because there are only 10 columns and we have more than 10 number of rows. So this one is 4x4 and this one is 2x2. So 2x2 square is surrounded by 4x4 square. The ring value is worked out in this way. We need to find the ring value, and to find the ring value there is a step 1 which says that add the number along the inside edges of the large square to get the L. When we add these number in the large square we will get the L. Similarly, step 2, add the number along the inside edges of the small square to get S. So when we add the values of the small square, this value will be S, this one will be S, and this one will be L. When we add values of the large square, we will get L. When we add the values of the small square, we will get S. Step 3, calculate the L minus S. This is the ring value. So to find the ring value will be equals to L minus S. For example, step 1, in the given condition, we have the L which is sum of the values of large square which is 3 plus 4 plus 5 plus 6 plus 16, then 26, 36, 35, 34, 33, 23 and 13. So when we add these values, we will get L. Similarly, when we add the values of the small square which are 14, 15, 24 and 25, when we add these values we will get S, and when we subtract S from the L we get ring value. This is a concept you should know to find the ring value. So when we add these values we will have 234, and the S is equals to the 14 plus 15 plus 25 plus 24. So when we add these values we will have 78. So ring value is equals to the L minus S, and in this case this is 234 minus 78, and which is equals to the 156. So in this case ring value is 156. Now part 1, 4x4 square ring. The example shows square ring 3. This is because 3 is the top left number in the ring. This is the square ring 3 for the 4x4 square because the top left number is 3. Similarly, if we take this square, so we will call it square ring 37 because this 37 is the number in the top left corner of this square. So this is square ring 3 because 3 is the top left number in the corner. Okay, work out the ring value for the square in the example we just solved it, in which ring value is equals to the 156 and L is 234 and S is 78. Ring value is 156. We just calculated. Now complete this table using part A and any pattern you notice. When we have square ring 1, it means this is the square. For 4x4, if we have square ring 1, means 1 is the top left corner of the 4x4 square. So L is equals to, in this case, 1 plus 2 plus 3 plus 4, this one, 14, 24, 14 plus 24, then 34, then 33, 32, 31, then 21 and 11. So this is the sum of the large square for the 4x4 with the square ring 1. When we add them, we will have 210. Similarly, this 4x4 has the small square, this one, and S is equal to the sum of the values of the smallest square, which is 12 plus 13 plus 23 plus 22. So this one is equals to 70. So the ring value in this case is equals to the L minus S, and in this case L is 210 minus 70, which is the S. So this one is equals to 140. So when we have square ring 1, L is equals to 210, S is equals to 70, and their difference is 140. Now we can find ring 3. We just solved in the example this one, which was 234 and 78. 234 and 78. So their difference is 156. Similarly, we can find the 4 by 4 square with the top left corner is 5. But I don't want sum the values of large square and then find the sum of the values of a smaller square. I will try to find the pattern. For example, in large column, you can see that when n is equal to 1, we have 210. When n is equal to 2, we have the 222. When n is equal to 3, we have the 234. So there is some pattern. You can see that there is a difference of 12. When we add 12 to the 210, we will get 222. When we add 12 to the 222, we get 234. When we add 12 to 234, we get 246. When we add 12 to 246, so this one will be 8, and this one will be 5, and this one will be 2. So 258. Similarly, there is a pattern in S 70, 74, 78, 82. You can see that this is a simple, just add the 4 to get the next number. Similarly, there is a pattern in ring value also 140, 148, 156, 164. We just need to add 8 to get the next value. So when we add 8 to the 164, we get 172. Okay. Find the expression in terms of n for the ring value. It can be observed that when we have n is equal to 1, the ring value is 140. Okay. When n is equal to 2, ring value is 148. So we know that this value is dependent on n. So we can say that when we multiply some value with some value, maybe p time n plus q is equals to ring value. This is the general term I will say. So what are these values? When n is equal to 1, so p time 1 plus q is equals to ring value, which is 140. This one is the equation 1. Similarly, when n is equal to 2, so p time 2 is plus q is equals to the 148, because in this case n is equals to 2. Sorry, 148. Because in this case n is equals to 2. So based on these two equations, this equation is p plus q is equals to 140, and this one is equals to 2p plus q equals to 148. So subtracting equation 1 from equation 2, so this one is equation 2, and subtracting equation 1, so p plus q is equals to 140. So we will have subtraction, so this will be cancelled out, and we will have p is equals to, and when we subtract 140 from 148, we will have 8. So p is 8. Plugging this p in equation 1, p is equal to, plug in equation 1, we have p plus q equals to 140. So 8 plus q is equals to 140. So q is equals to 140 minus 8, which is equals to 132. So you can see that the general equation, this one, and we have calculated the p and q. P is 8 and q is 132. So this one is equals to p times n, means 8 times n plus q, which is 132, and this one is equals to general term for the ring value. So this is the expression. So 8n plus 132. You can counter check by plugging n is equal to 3. For example, when we have the 8n plus 132 equal to ring value, when n is equals to 3, we are counter checking it. When n is equal to 3, we should have 156. So 8 times 3 is plus 132 equals to ring value, and in this case ring value is equals to 132 plus 8 times 3, which is 24, and this one is equals to 156. So ring value is 156. So it confirmed that the expression we find is right. Find the ring value for the square ring 753. This is the n. So in this case, ring square ring 731. So we have given n is equal to 731. And by using this formula, we can find the ring value. So ring value is equal to 8 times n plus 132, and in this case n is equals to 731. So plus 132, 8 times 731 is equals to the 5848 plus 132. So this one is equal to 5980. Okay. Now question number 2. 6 by 6 squaring. So this is the 6 by 6. 1 2 3 4 5 6 and 1 2 3 4 5 6. This is a 6 by 6 square. Surround the 4 by 4. This one 1 2 3 4 1 2 3 4. So 4 by 4. This square has the width of 6. So we call it width of 6 because it is the 6 by 6 square. Now complete the working to find the ring value for the square ring one. This is a square ring one because this one represents the top left value of the 6 by 6 square. So L is equals to 1 plus 2 plus 3 plus 4 plus 5 plus 6, 16, 26, then 36, then 46, then 56, 55, 55, 54, 53, 52, 51, 41, 31, 21, 11. When we add them, we will have 570. Similarly, there is a small square which is the 4 by 4, this one. So when we add these value, we get the value of s, which is 12 plus 13 plus 14 plus 15, 25 plus 35 plus 45 plus 10, 44. 44, 43, 42, 32, and then 22. So when we add these value, we will have 342. And the ring value is equals to the L minus S, and in this case L is 570 minus 342, which is the S. So difference is 228. Part B, complete the table. We need to find the value of S when n is equal to 1. So we just calculated this one because this one is the squaring 1, because the 1 is on the top left corner of the 6 by 6. In this case S is, we just calculated, which is 342. 342, and ring value for this case was 228. Okay. Now when the squaring n is equals to 2, so this one will be the 6 by 6 square, and in this case the 4 by 4 square will be this one. And we need to add, to find the value of s, we will add these values: 13 plus 14 plus 15 plus 16, then 26, 36, 46, 45, 44, 43, 33, 23. This is the one method to find the value of s. But I don't want to go for the long calculations. I will go for the pattern reading. For example, start from 266. When n is equal to 3, we have the value of s, which is 366. When n is equal to 4, we have the value of 378. What is the difference? I think 12. Yes, 12. So when we add 12 to 366, we get 378. When we add 12 to the 378, we get 390. So similarly, when we add 3 to 12 to the 342, we will get 2, 1. And this one will be equals to 4, and this one will be 5, and this one will be 3. Now you can check it. When we add 12 to the 354, we get 366. Now just try to find the pattern in ring value also. When we have n is equal to 1, we have the ring value of 228. When we have n is equal to 2, we have the ring value of 236. What is the difference? I think 8. When we add 8 to the 236, so we will have 4 and 1 carry, and then 4 and 2. When we add 8 to this value, we will have 252. And when we add 8 to 252, we get 260. Now find the expression in terms of n for the ring value. We will use the same method. When n is equals to 1, we have the ring value of 228. When n is equals to 2, we have the ring value of 236. When you find the pattern and there is a linear pattern, for example, you just get the next term by adding or subtracting. So there should be some equation of line. So ring value will be equals to p time n plus q. This is the equation of line. When we have the n is equal to 1, So when n is equals to 1, we have the ring value which is 228 equals to p times n means 1 plus q. So this one is equals to p plus q is equals to 228. This is the equation 1. Similarly, when n is equals to 2, we have the ring value is 236. 236 equals to 2. Pn means p times 2 plus q. So in this case, you will have 2p plus q is equals to 236. Okay, this is equation 2. So these are two equations. We have two variables, so we can solve these two equations simultaneously to find the value of p and q. So subtracting equation 1 from equation 2, so p2p plus q is equals to 236 minus p plus q is equals to 228. Subtracting, so we will cancel the q and we will have p is equals to 8. So we have the p is equals to 8. Plugging this p in equation 1, we will have p plus q is equals to 228 and p is 8 plus q is equals to 228 and we will have q is equals to 228 minus 8. So q is equals to 220. So the general term ring value is equals to p times n means p is 8, 8 times n plus q which is 220. So this is the general term for the 6 by 6 square to find ring value 8n plus 220. Now part D, square ring has the ring value of 1028. Find the number in the bottom right square of this square ring. First we find the value of n and we know that we have the ring value which is equals to 1028. So we need to find the value of n. So we know that ring value is 8n plus 220 is equals to 1028. So 8n is equals to 1028 minus 220 and this one is equals to 808. So n is equals to 808 over 8 and this one is equals to 101. This is the value of n. It means this value is the top left corner of the square 6 by 6. For example, this is a 6 by 6 square and we know that the top left corner value of the square is n and this value is 101. We need to find the bottom right. So bottom right is this one. Now for any square 6 by 6, if this one is the n, then to find this value we need to move 6 unit by right and 6 unit towards downward. So from n value we will increase by 1, 2, 3, 4, 5. So we will increase by 6 to get to this position, means top right. So this one will be 101, 102, 103, 104, 105, 106, 106. Now when we move downward, so it will increase by 10. Each box will increase by 10, means 16, 6, then 16, 26, 36, 46, 56. So in this case it will be 116, then 126, 136, 146, 1, 2, 3, 4, 5, 6. So 156. So this will be 156. When value of n is 101 for the 6 by 6 square, so its bottom right will be 156. Question number 3, W by W square ring. For the width of the square ring is W. For the square ring in question 1, width was 4. For the square ring in question 2, width was 6. Okay, you can see that when we have the 6 by 6 square, width is 6. This one. Similarly, when we were dealing 4 by 4 square, the width was 4. For the W by W square ring, the expression for the ring value is 8n plus kW minus k. Where for the 8 by 8 square ring, the expression for the square ring is 8n plus 308. For width of 4 from question number 1, we have 4 by 4 square and the ring value was equals to 8n plus 132, I think so. Let me check. Yes, 132. 132. From question 2, there was a width of 6 and the square was 6 by 6 and the ring value was equals to 8n plus 220. It is given that for the width of 8 means 8 by 8 square, the ring value expression is 8n plus 308. So given W is equal to 8 means 8 by 8 square. So the ring value expression is equals to 8n plus 308. For the W width, so means we have the W by W square. The expression for the ring value is 8n plus kW minus k. Find the value of k. Write down an expression in terms of n and w for the ring value of w by w squaring. It is given that for width 8, we have the ring value expression is equals to the 8n plus 308. For the width of w, we have the ring value expression which is 8n plus kw minus k. This is a generalized expression for the W width, or you can say the W by W square. If we plug W is equal to 8, this width value is equals to 8 times N plus K times W means K times 8 minus K. And this one should be equals to this ring value. So we can say that 8N plus 308 is equals to 8N plus K times 8, it means 8K minus K. So 8n will be cancelled out and we will have 308 equals to the 8k minus k means 7k. So we can say that k is equals to 308 over 7 and this one is equals to 44. K is equals to 44, and when we plug this value of k in the generalized expression for the width k, we will have 8n plus kw minus k. When we plug k is equal to 44, we will have 8n plus 44w minus 44. This is a generalized expression in terms of n and w for the ring value. So the ring value in terms of n and w is 8n plus 44w minus 44. Okay. Question number 4. The diagram show two squaring shaded and the lined. This one is shaded and this one is lined. The large square ring has the width of w. This one is the width of w. When we have the w by w, the ring value should be equals to 8n plus kw minus k, and we calculated the value of k, and so this one is the ring value for w by w square or for the width w. Okay, the large square is the w by w, and the number in the top left corner is n. For the w by w, top left corner number is n. Use algebra to find what is always true about the difference between the two rings. This is the small square and this one is the large square. And we need to find the difference of the ring value for these two squares. So I will call it ring value S and this one is ring value L. Now we need to find the difference of these two ring values. So we need to find the ring value L, which is the ring value of large square, minus ring value of the small square. So this is the difference we need. For any square, any w by w square which has the width of w, the ring value for the w width square is equals to the 8n plus 44 width minus 44. We just calculated this expression from the part A. Now same expression will be applied for the large square and for the small square both. For large square, we have the width of w and the value which is the top left corner of the large square which is n. So this one is n. So we can use these information to find the ring value of the large square. So the ring value in this case 8n plus 44w minus 44. Now we need to find the ring value for the small square. For small square, in this case, in a small square, this value is n dash. So this one is n dash. Okay, we don't know the width. Similarly, in this case, this one is the width for the small square. So this one is w dash. Width w dash. Now, how we can find it? You can see that large square has the width from here to here, where small square has the width from here to here, which is the w dash. Now, if we eliminate two boxes, this box and this box, from the large width, we get the small width. Okay. So in this case, this one is equal to w minus 2. Okay. Now, what will be the value of n dash? Now, with respect to this, I want to show you. This is a large square which has the left top corner value, which is n. So the small square will be this one. So you can say that the small square top left corner value should be 11 greater than the large n value. So this one is n dash, which is the 11 greater than the n. So we can say that n dash is equals to n plus 11, because this value is 11 greater than this value. Okay. Based on these information, the ring value, generalized ring value, is equals to the 8 n dash plus 44 w dash minus 44. This is the ring value for the small square, and in this case n dash is the top left value of the small square and w dash is the width of the small square. 8 times n dash means n plus 11 plus 44 times w dash, which is n w minus 2 minus 44. So when we calculate it, it is 8n plus 88 plus 44w minus 88 minus 44. So this one will be cancelled out and we will have 8n plus 44w minus 44. This is same as this value. So we can say the difference is equals to the ring value of large square minus the ring value of the small square, and ring value large is equals to 8n plus 44w minus 44 minus ring value of small, which was 8 and minus plus 44 w minus 44. This one will be cancelled out and we will have zero difference. So in every case, ring value for the connected two square always zero. Now let's move to the modeling section. The topic is lift. You are advised to spend no more than 45 minutes on this section. In this section, you will model the upward force lift that an aircraft wing makes when it flies through the air. Different wind shape make different amount of lift. This task is about one wind shape and the lift that it makes. We need to know the air density, the mass of 1 cubic meter of air to calculate the lift. This table shows the air density at different height above sea level. When we have the height of 0 kilometer, the air density is 1.225 kilogram per meter cube. Similarly, when the height is 1 kilometer, we have the air density of 1.1160 kilogram per meter cube. Similarly, this is the air density for the 5 kilometer height, and this is the density for the 10 kilometer, 20 kilometer, and so on. The value of the shaded cell are plotted on the grid. Okay, these are the values of the air density with respect to height above the sea level. Okay. Part A, plot the remaining 2 points. We can see that this is the 0 height. We have the density just above the 1.2. Then we have the height of 1 kilometer and we have the air density of 1.116. When height is 5 kilometer, we have the density which is around 0.7. Now we need to plot these 2 points, and we know that at the height of 10 kilometer, air density is 0.414. So this is the height which is 10 here, and the air density is just above the zero point 0.4. So this is 0.4, so it will be here. Similarly, when the height is 20, the air density is 0.088. 20.088. This is just below the 0.1. So this one is 0.1. So just below the 0.1, this one. We have plotted the remaining points. Now let's move to the part B, model A. The possible model for the air density is D is equal to 195 over 39H plus 160. For the H is less than or equal to 50 and greater than or equal to 0. Sketch this model on the grid. Label the sketch A. First we sketch this model. We know that air density with respect to height is given, which is 195 over 39 times h plus 160. When h is 0, we will consider these sides 0, 1, 5, 10, 20, 32, 40. So when height is 0, d is equals to 195 over 39 times 0 is 0, 0 plus 160, so it will be 160, and this one is equals to the 1.2185. 1.21875. Okay. Now when height is equals to 1 kilometer, so d is equals to air density is equals to 195 over 39 times height, which is 1. So 39 times 1 is 39. So this one is 39 plus 160. So this one is equals to the 195 over 199, and this one will be 0.979. When height is equals to 5 kilometer, d will be equals to 195 over 39 times height, which is 5 plus 160, and this one is equals to the 0.54929. Similarly, when height is equals to 10, we will have d is equals to 195 over 39 times height, means 39 times 10 plus 160, and this will be equals to the 0.3545. When height is equals to 20, we will have d is equals to 195 over 39 times height, mean 20 plus 160, and this one is equals to the 0.207. Now height is 30, so d is equals to 195 over 39 times 30 plus 160, and this one is equals to the 0.1466. And when height is equal to 40, d is equals to 195 over 39 times 40 plus 160, and this one is equals to 0.1133. And when height is equals to 50, air density will be 195 over 39 times 50 plus 160, and this one is equals to the 0.0924. When height is 0, density is 1.218. 1.218 is just here. Similarly, when height is 1, the value is 0.979. 0.9 here. Similarly, when the height is 5, we have the value of air density, which is 0.549. 0.549 here. Similarly, when height is 10, we have the density 0.35. So just above the 3 points here. When we have the height 20, density is 0.207. 0.207. Okay. When we have the height 30, 0.14 is the density. 0.14. Just here. When we have the height is equals to the 40, we have the density 0.113. 40 and 0.113. So this just here. Okay, and when height is 50, we have the density 0.09, just below the point 1 here. When we join these points, so we have A. Let's plot the previous model which was given. So this one. So this one is actual air density. Now, estimate the range of height when the model will give the value below the actual air density. This is the actual, and this one is the model A. Okay, this is the point before which the actual air density is greater than the model value, and after that the actual density is below the model value. If I call this point K, so I will say that when height is less than and equal to K, actual air density is greater than the model value. H is less than and equal to K. At this condition, model value is less than the actual air density, and K lie in between 10 to 20. So K is less than and equal to 20 and greater than and equal to 10. So this is the range. Similarly, estimate the range of value of H when the model will give the value above the air density. You can see that from this point we have the larger value in the model A as compared to the actual air density. So we can say that when H is greater than K, we will have the model value greater than the actual air density, and K will be in between. Part B. Another possible model is D is equal to 1 over log of 2h plus 3 minus 0.5, where h is less than and equal to 50 and greater than and equal to 0. Sketch this model on the grid. Label the sketch B. Now new model is D is equal to 1 over log of 2 times h plus 3 minus 0.5. Now when h is equals to 0, so we will have d is equals to 1 over log of 2 times height, which is 0, so log of 3 minus 0.5, and this one is equals to the 1.5959. Similarly, when height is equals to 1, d is equals to 1 over log of 2h means 2 log of 2 plus 3 minus 0.5. So this one is equal to 0.93067. When height is equals to 5, we will have d is equals to 1 over log of 2 times height means 2 times 5, which is 10 plus 3 minus 0.5, and this one is equals to the 0.3977. Similarly, when height is equal to 10, we will have d is equals to 1 over log of 2 times height means 2 times 10, which is 20 plus 3 minus 0.5, and this one is equals to 0.2343. Similarly, when height is equals to 20, then d is equals to 1 over log of 20 plus 3, or 2 times height means 2 times 20, which is 40 plus 3 minus 0.5, and this one is equals to the 0.112. So when height is equals to 30, d is equals to 1 over log of 60 plus 3 minus 0.5, and this one is equals to 0.055. Similarly, when height is equal to 40, air density is equals to 1 over log of 80 plus 3 minus 0.5, and this one is equals to the 0.021. When height is equals to 50, air density is equal to log of 100 plus 3 minus 0.5 equals to, so this one is negative 0.003. Okay, let's plot this graph. When we have the height 0, we have the 1.59, which is around 1.6. So this will be the point 1.59. When we have the height 1, we have the point 0.93 here. When height is 1, we have the density 0.93. So this one. When we have the height 5, we have the density 0.39, just below the point 4. When 5, just below the point 4. This one. When height is 10, density is 0.23 and 0.23, just here. Similarly, when height is 20.11, 20.11 here. When height is 30, we have the value of density, which is 0.055. Height is 30.05, so almost here. When height is 40, we have the value of 0.021. And when we have the height 50, the value is negative. When we join these points, okay, so this is the sketch B. Part A, estimate the range of value of H when the model is valid. You can see that this is the actual and this one is the model B, and approximately from this point to this point they are feasible or nearest to the actual value. You can see that this graph B is nearest to the actual air density graph or sketch starting from this point. After 45, the model B become negative almost. It become negative in 48.5. I just calculated. So model B is nearest to the actual graph near to 45, we can say that. And starting from 15 to 20, we can say that model B graph is valid with respect to the actual air density. So we can say that height should be less than and equal to 45 and greater than and equal to 15. Comment on the model when H is 50. We just calculated that when H is 50, the value of air density is negative. Air density is negative. Now question number 6. To make lift an aircraft wing is angle to the airflow. This is called angle of attack. This is the angle of attack with respect to airflow. As the speed of the aircraft decrease, the angle of attack, which is a degree, increase to get more lift. As the aircraft speed of the aircraft decrease, the angle of attack increase to get more lift. The amount of lift depend on the quantity known as lift coefficient, which is C. This table show how lift coefficient changes for different value of the angle of attack. The possible value for the C is equal to m plus n times a minus 17 whole square, where m and n are the constants. Use a is equal to 0 and a is equal to 20 to find two equations each in terms of m and n. Give equation in its simplest form. When a is equals to angle of attack is equals to 0, this one, the lift coefficient is 0.55. So we have the equation of lift coefficient, which is C is equal to m plus n times a minus 17 whole square. Now first we plug a is equal to 0. Okay, so C is in this case is 0.55. So C is 0.55. So when we plug 0.55 is equals to m plus n time a, which is 0 minus 17 whole square. further solving, we will have 0.55 equals to m plus negative 17 squared is 289, and 289 times n is 289n. So this is the equation 1. When a is equals to 20, we have the value of lift coefficient c is 1.66. So c is 1.66. So plugging these two values in equation of lift again, we will have 1.66 equals to m plus n time a minus 17 means 20 minus 17 whole square. So 1.66 equals to m plus n, and 20 minus 17 is 3, 3 square is 9. So we will see that m plus 9n is equals to 1.66. So this one is equation 2 and this one is equation 1. So m plus 289 n is equals to 0.55, and m plus 9 n is equals to 1.66. Find the value of m and the value of n and write the model for c. Give each value correct to two significant figure. Okay, we have the equation 1, which is m plus 289 n is equals to 0.55. And we have the another equation, which is m plus 9n equals to 1.66. Just subtracting, we will cancel this m and we will have 280n is equals to 0.55 minus 1.66 is negative 1.11. So n is equals to negative 1.11 over 280. So this one is equals to negative 0.0039, or you can say that negative 0.004. Now plug this value of n in equation 2. Plug n is equals to negative 0.0040 in equation 2. And equation 2 is m plus 9 and equals to 1.66. And in this case, m plus 9 n means 9 times 0.0040 equals to 1.66. Sorry, this one is negative. So m 9 times 0.004 is negative 0.036 equals to 1.66, and m in this case is equals to 1.66 plus 0.036. So m in this case is 1.696. So we have calculated the value of m, which is 1.696, and n is equals to 0.004, negative 0.0040. And when we plug these m and n in the equation of lift coefficient, we will have c is equals to m plus n time a minus 17 whole square. Plugging this m and n, we will get m, which is 1.696. N is negative, so this will be negative 0.0040 time a minus 17 whole square. Use your model to find the maximum lift coefficient for this wing. We have the lift, which is 1.696 minus 0.0040 a minus 17 whole square. Okay, this is the equation of lift coefficient. We can achieve the maximum value, this one, if this value becomes 0, because this one is positive. When this value is positive, multiply with negative value, it will be negative. So this will decrease the value of 1.697. If we consider a is equals to 17, so this whole factor will be equal to 0. So we will get maximum lift coefficient, which is 1.696. So we can say that maximum is equals to 1.696, which is possible when a is equals to 17. Okay. Question number 7. The model for the lift L newtons that an aircraft make is L is equal to dv square AC over 2, where d is air density, v is the speed, a is the wing area, and c is the lift coefficient. An aircraft has the wing area of 125 meter square. We have the wing area means A, which is equals to 125 meter square. Okay. It flies at the height of 12 kilometer above the sea level. So we have the height which is 12 kilometer at the speed of 210 meter per second. So V, which is 210 meter per second, with the angle of attack. So angle of attack A degree is equals to 3 degree. Use question number 6b and the model A in question number 5b to calculate the lift for this aircraft. Give your answer correct to two significant figures. In question number 6, we study the lift coefficient, which is C. And in question number 5b, we discuss the air density. So this one is air density D. And we study the density with respect to height and the lift coefficient with respect to angle. Now we need to calculate the lift which required the value of C and value of density. So we will calculate density with respect to height from the question 5b, and we will calculate the lift coefficient with respect to angle from the question number 6b. This one is the model for the question number 5b. And the model was D is equal to 195 over 39 H plus 150. From question number 5b, D is equals to 195 over 39 times H plus 160. It is given that height is equals to 12 kilometer. So air density in this case will be 195 over 39 times height, which is 12 plus 160. And this one is equals to the 195 over 468 plus 160. And this one is equals to 195 over 628. For the solving, we will have air density which is equals to the 0.310509. Okay. Now we need to find the lift coefficient from the question number 6b. From question number 6b, we calculated the lift coefficient which was 1.696 minus 0.004 time a minus 17 whole square. And a is the angle of attack, which is 3 degree in this case. So plugging 1.696 minus 0.004 times 3 minus 17 whole square. So C is equals to the 1.696 minus 0.784. So this one is equals to 0.912. Now we need to find the lift. We have the value of C now, and we have the value of air density. We need to find the value of lift, which is equals to the d time v square, d time v square AC over 2. And in this case, d we just calculated, which is 0.31 time v is the speed which is given, which is 210 square, time a is the wing area, which is 125, and C we just calculated the lift coefficient, which is 0.912 over 2. So this one is equals to 779247. So we need to convert it into two significant figures. So we can say that 780,000. So this one is 780,000 in Newton. I hope you learned something from my lecture. Please share with your friend and subscribe. Thank you very much for watching my videos.